Think like Tesla.
Think like Tesla, Micah here. I have an actual free energy device. I'm going to show it to you right now. I got it at my corner grocery store for $1.99. And here it is. It's got a solar cell. It requires no fuel. Requires no internal. It requires no source of energy that you would ever pay for. Right? The sun is free. So these are the kind of free energy devices that can actually exist according to the rules of physics.
In this house, we obey the laws of thermodynamics.
So cover it up. Lights up. Okay, we can tear this thing down. See what's inside it. All right, not much in here, is there? So it's got a solar cell. Pretty small one, actually. Leading to the circuit board. This is a AAA nickel metal hydride battery. Better if it's on frame. And a little circuit board here. It has only a resistor and a 4-lead integrated circuit. And this switch. That's it. So this is actually a pretty clever IC. Handles all the charge controlling and everything. And it handles turning the light on and off depending on how much solar influx is coming into this solar cell here. Check out this other video, put the link below, from Electroboom, where he shows off some other alleged free energy devices and explains what the gimmick is behind them. Most of the free energy videos you see on YouTube are probably outright frauds, and a small percentage of them are perhaps attributable to some kind of measurement error. But yeah, free energy is not a thing.
And this perpetual motion machine she made today is a joke. It just keeps going faster and faster.
A solar panel of this size, it's about 3 centimeters by 3 centimeters. Let's call it 10 square centimeters, just to make the math easy. Let's say 1 watt of sunlight was shining on this, and the power extracted out through the leads was 100 milliwatts. We'd say the efficiency of it is 10%. But if you had it somehow, if you had 1 watt shining on here and 10 watts coming out, that's what folks would call over unity. Somehow you're getting something for nothing. Right, but the math doesn't quite work out, because if we really had a device that could put out 10 watts on these leads, I could redirect 1 watt of that back out into a light, shine it on here. Now we'd have 0 watts in and 9 watts out. What's the percentage efficiency for that? Divide by 0 error. So when the math starts giving you infinities, that's a sign that you're doing something wrong. All right. And it's worth noting, Tesla himself, as far as I can tell, did not believe in overunity. He often talked about exploiting the wheelwork of the universe and harvesting readily available energy that's all around us. But, yeah, that's a good idea. That's what this thing does. That's what many other devices do. So that's a good thing to experiment with. There's a whole field called energy harvesting. Only fairly recently have devices gotten low power enough that we can actually extract energy out of the air, get enough useful energy to power devices. Some of these are devices that only wake up once a minute or something, take a sensor reading, send it off, go back to sleep. But the technology is getting better and better, and we're going to talk about some of that more later on here. I have some energy harvesting chips. We're going to wire them up and see how much energy we can pull out of the thin air right here at the workbench. It's important to have the right expectations when we go into this. So take a look at this chart here. This shows various energy densities from different ways of extracting energy. Now I'm grabbing this from a sciencepub.com website. I'll put the link below. Different kinds of energy have different things that going for them and different disadvantages as well. So let me hop over to the edge of my workbench here. I did not put any design into this antenna. I just stuck up a big piece of aluminum foil and hooked an alligator lead onto it. This is my version of a wideband antenna. The object is to collect as much energy as we can off of the ambient air. Now I have a suspicion a lot of what it collects here is just 60 hertz noise coming from the wiring on the walls and stuff. But some portion of it is probably Wi-Fi signals, AM, FM radio stations that might be nearby, wireless sensors. Hopefully not, but it could be microwave ovens that are leaking, any number of different things. Let's hop over to the side of my workbench here and see what's going on. Okay, we're on the shaky cam here, so hope you don't get too seasick. At the edge of my workbench, you can see all the way up here is a big old sheet of aluminum foil taped together with conductive foil. And at the bottom here, we have a little circuit. I'll show you the diagram for this in a second. And it's pulling energy out of the air and storing it in these two black capacitors. So let me see if I can measure the voltage across the capacitors on my trusty meter here. Okay, 41.3 volts. It's actually going down a bit. Perhaps the load, the 11 meg ohms of resistance from my meter, is enough to drain some of the power out of this. But that's not too bad. 38 volts across those capacitors. A couple days ago, I foolishly hooked an LED across that to see if there was enough energy to blink the LED, and it actually made a spark and completely destroyed my LED. Hey, Future Micah here. I just wanted to jump in and clarify a bit about this 40 volts. Ooh, sounds like a lot, 40 volts. But actually, if you do the math, not so much. So how much energy is actually stored in a capacitor? The formula is 1/2 times the capacitance in farads, and this was only 47 microfarads, times the voltage squared. And there were two capacitors, so you can see the math here. 2 times 1/2, 47 microfarads, times the voltage squared. The voltage was across each capacitor was only 20 volts. All right, so we're getting a total of 18.8 millijoules. Compare that to the energy charts that we saw before, the energy density. Not a lot. All right, it's about 17 times the mechanical work done when depressing a key on a computer keypad. So typing in your name and password on your keyboard probably uses as much energy as this thing harvested over several days. So let's go back to the workbench and I will show you what the circuit is doing. Here's what we were just looking at. In the diagram here, you have an antenna. This is the huge piece of tinfoil. These two capacitors are basically DC blocking capacitors. So any charge that builds up on these capacitors can't flow through. Notice all these diodes. Diodes are like a one-way valve. So they only let current flow through in one direction. And they're all pointing in a loop with these capacitors as part of the loop. So it's like a ratchet. It easily moves in one direction that puts more charge on the capacitors, and it does not like to go in the other direction. So the wiggles in the electricity that come from this antenna, whatever frequency they are, they always end up getting added to the values in these capacitors. So it's storing energy. Now, if you looked closely at the construction earlier, you notice there was two sets of diodes in there. It's important to use the right diodes here. The first set I used were just regular, they're called small signal diodes. Did not handle the radio frequencies well, and I got terrible results. Since I switched to the 1N5711 diodes, work way better. It can get voltages above 50 volts on these capacitors. So if you build the circuit, be sure and use, for your main storage capacitors, use high value voltage capacitors. Mine are 50 volts each, and they're in series, so I could handle up to 100 volts here.
Teslanomicon.
Today's book recommendation is Broken, Bronze Age Time Travel by yours truly. We've got a Silicon Valley geek named Shiloh, and he finds himself thrown back in time to the Bronze Age, where he has to reinvent technology. If you've enjoyed books like A Connecticut Yankee in King Arthur's Court, or just time travel in general, you will appreciate this book. Oh yes, and since we're talking about fiction here in this episode about free energy, it's worth noting that a type of free energy device does feature into the plot. Not too much of a spoiler, but something to look forward to. So if this is your kind of thing, please check it out, by all means. Think like Tesla fans. Help me out here. Give a big thumbs up to this episode if you thought it was useful. And check out the Geek Thoughts store in the episode notes below.